Hello, everybody. In Module 6, I discuss information processing, cost, and rational inattention. Module 6 has 6 lessons. Today, we focus on Lesson 5, rational inattention and aggregation. We know that financial statements usually provide summarized, aggregated information. A common question is, why not provide more details? If we assume infinite information processing capacity and consider a single-person decision-making setting, then providing more information cannot be worse. It's at least weakly better, because if the additional information is useless, you can always ignore them. However, with limited attention, more information may actually result in investors being worse off, because they would extract less information. And the reason is they do not know which part of information to process when you give them too much information, and they have limited information processing capacity. The discussion is based on Lu 2022 JAR paper. Now let's look at the set of the model. It's a typical single investor decision-making setting. There is a firm with fundamental theta that is normally distributed with mean 0 and variance sigma theta squared. There is a representative investor. The investor chooses the amount of investment to maximize the utility, which is theta k minus 1/2 k squared, which means that the optimal investments would be expected value of theta conditional on the representative investor's information set. More information is going to help with more efficient investment decision. This omega information set depends on the reporting regime as well as the investor's information processing capacity. The paper considers 2 reporting regimes. The first is a summary regime, which means that it just provides a noisy summary of theta. So theta plus gamma, where gamma is some noise normally distributed with mean 0 and variance sigma gamma squared. The second is regime D, or the details regime. Consider 2 components of theta. And for simplicity, assume that they're independently distributed, theta x and theta y. They're all normally distributed. Theta x has variance sigma x squared, theta y has variance sigma y squared. And theta, of course, is just theta x plus theta y. Without loss of generality, we assume that theta y is the more uncertain component a priori, which means that sigma y is bigger than or equal to sigma x. And this assumption implies that sigma theta squared is equal to sigma x squared plus sigma y squared. As you can see here, aggregation provides strictly less information, because in the details regime, theta x and theta y gives you information about theta. But in the summary regime, you don't know about theta. You only know about theta plus gamma. So if investors have infinite information processing capacity, they would prefer the details regime. However, investors do not have infinite information processing capacity. The investor needs to process to generate information. The paper assumes that investors are subject to a rational inattention constraint, which means that the mutual information between the report and investor's information set has to be smaller than some upper bound. The C can be seen as representing investors' information processing capacity. Higher C representing higher information processing capacity. In a summary regime, investors' information processing would result in a signal theta plus gamma plus epsilon. For epsilon, normally distributed with mean 0 and variance sigma squared, is an independent noise. So this just means that because investors have limited information processing, they cannot observe theta plus gamma. They observe theta plus gamma plus epsilon. And the rational inattention constraint can solve for sigma squared. We can see that sigma squared is going to decrease the information processing capacity, which is intuitive. The more capacity you have, the more you can process, and the lower the variance of the noise. And sigma squared increases with prior uncertainty. That's also intuitive. When prior uncertainty is high, given the same amount of information processing capacity, you're still going to end up with a more noisy signal. In the details regime, investors' information processing results in 2 signals. One is theta x plus noise, another is theta y plus noise. Epsilon 1 is normally distributed with mean 0 and variance sigma 1 squared. epsilon 2 is normally distributed, mean 0 and sigma 2 square variance. They're independent. Rational inattention constraint can result in a relationship between sigma 1 square and sigma 2 square. And we can see here the two variances, there are substitutes. If I pay more attention to y, for example, then the variance of epsilon 2 is going to reduce, or the precision P2 is going to increase. But that means I have to pay less attention to x, which means that sigma 1 square is going to increase, so P1 is going to decrease. Because this is a single investor decision-making setting, so the expected utility is very nicely written as proportional to the difference between the ex-ante or the prior variance of theta and the exposed variance of theta, conditional investors information set. So the lower the posterior variance, the higher the expected utility. Under summary regime, we can calculate the posterior variance of theta to be this. And under the details regime, however, we need to first solve for the attention allocation between the two signals, x and y, before we solve for the posterior variance. So it can be shown that when the capacity is sufficiently small, all of the attention is devoted to processing theta y. When the capacity is not that small, you're going to process both theta y and theta x. However, more attention is going to be devoted to theta y. And that results in the solution for sigma 1 square and sigma 2 square. And here's the intuition. This intuition comes from the general insights from rational inattention models that we discussed in lesson 3 of this module. Details with higher prior uncertainty receives more attention because I know less about that and I have limited attention. So I want to devote more attention to things that I know less about because this is a more efficient way to spend a limited amount of attention. For something that I already know a lot about, paying attention does not pay off that much. In the extreme case, let's say, supposing in the extreme case, I know perfectly about x, then there is no point in allocating any attention to x. And so we have sigma 1 square and sigma 2 square. So we can calculate the posterior variance of theta conditional on x and y correspondingly. And we compare the two posterior variants. So the result is summary is going to dominate details if and only if sigma gamma square is smaller than some threshold and the capacity is smaller than some threshold. So here's the intuition. In the details regime, investor needs to divide attention into processing each component. So that requires more attention. When investors' attention is constrained, they do worse in processing multiple signals. And if summary regime is not sufficiently noisy, then in the summary regime, they actually get a pretty good signal. So summary regime is going to dominate. We can do one more comparative statics. So let's see, because we know sigma theta square is equal to sigma x squared plus sigma y squared. So we can express sigma x squared and sigma y squared as a proportion of sigma theta squared. And that sigma y squared equals w sigma theta squared. Because sigma y squared is bigger or equal than sigma x squared. W is between 1/2 and 1. In this case, we can show that the threshold decreases in w, which means that when w is higher, the details regime is more likely to be better. Why is that? Because when w is higher, then sigma y squared is much higher. So in this case, you know a lot less about y, but you know a lot more about x. So investors can efficiently allocate more attention to the more noisy component. In the extreme case, let's say when w equals 1, then investors know perfectly about x. Investors are going to devote all of their attention to y. And that results in completely efficient attention allocation. So from the results, we have the following empirical implications. Let's say we have some shock. This shock results in more disaggregated disclosure. And that's going to result in less efficient information processing and less efficient price due to less efficient information processing. If investors are more attention constrained, for example, you have a higher proportion of retail investors, the magnitude of information gained through disaggregation is smaller. Let's say the aggregated signal is already quite precise, or the disaggregated signal does not really provide much information. And then each detailed component has similar uncertainty. We talk about summary versus details in the main part. However, sometimes when you consider accounting rules or disclosure rules, disaggregation is in the form of summary plus details. For example, you recognize the summary in the financial statements and you disclose the details in the notes. In a single representative investor decision-making setting, summary and details cannot do worse because investors can always replicate in the summary and details regime what is done in a summary regime. You just pay the same attention to the summary and ignore the details, then you replicate the result. However, Lu's paper shows that when you consider coordination among investors, so for example, if you are going to invest, I also want to invest. If you don't want to invest, I also don't want to invest. So this coordination means that we want to take the same actions together. In those settings, summary might be better than summary and details, because when you have both summary and details, investors may fixate on details because details provide more precise information. But fixating on details could harm coordination. So to conclude, in a single-person decision-making setting with perfect information processing, more disaggregated information cannot do worse. However, if we consider limited information processing capacity, more disaggregated information could be worse because processing disaggregated information consumes more attention. And so it will hurt investors' decision-making when the processing capacity is sufficiently small. This paper focuses on a reduced form way of modeling investors' decision-making. So we talk about investors, but there is no price. Next lesson, we're going to explicitly model price response to disclosure in the presence of information processing constraint. If you want to test your understanding of this lesson, a review quiz of this lesson can be found on the link provided in the slides. Thank you very much.